Alright, so this is going to be a video about antiderivatives. And basically what an antiderivative is, it's based on its name, it's the opposite of a derivative. So say we started with a derivative like 4x to the third. The antiderivative of it would be whatever the function is where you have to take the derivative to get the 4x to the third. So basically you're looking for a function whose derivative is 4x to the third. And based on your knowledge and understanding of the power rule, you should be able to guess what that function is. And that function is basically going to be f of x will be equal to x to the fourth. Because the derivative of x to the fourth would be 4x to the third. However, there's also another thing that you can add to this derivative, or to this antiderivative. It's a constant c. And c can be any number, positive, negative. That's just a constant number. And the reason why you have to add this plus c in there is because it's not just x to the fourth plus 0. It could be x to the fourth plus 2. And the derivative would still be 4x to the third because that 2, the derivative of that 2 would be 0 and it wouldn't show up in the derivative. So it's really important to always add that c, which is called the constant of integration. Okay, it's called the constant of integration. We're going to talk more about that in a little bit. Alright, so what I did over here is I kind of broke down the parts of an antiderivative. And this first part right here, it says dy over dx. It's the same thing as this f prime right here. If you remember your derivative notation, this just means the derivative of y with respect to x. And I'm setting it equal to some function. Okay, so I want to find the antiderivative of this dy over dx. So that means I'm trying to solve for that y. So I'm trying to get that y by itself. So the first thing I did up here was I multiplied both sides by dx. So I multiplied the dx, both sides, it canceled out over here, so I have dy, and then I multiplied the dx over here, so I have f of x times dx. Now to get rid of this d, I have to do the antiderivative, or anti-differentiation of both sides. And what this is called is integration, indefinite integration. So I have this right here, it's this integral sign, and basically you'd be adding an integral sign to both sides, and it would cancel out the d, so you wouldn't have the dy, you would just have y by itself. And then the integral sign would be on this other side right here. So then you have the integral, or the antiderivative of this f of x, and this dx right here is called the variable of integration. So you're basically taking the antiderivative of this f of x with respect to this dx. So it's similar to our derivative notation where you have to take it with respect to d of x on the bottom, or dx on the bottom. Here though it's being multiplied, but you still need that variable of integration so you know what you're integrating with respect to. The f of x, this function, would be called the integrand, and the integral sign is just this S-looking shape here. What this ends up breaking down to, or being equal to, is the antiderivative. I did a capital F to kind of make it different than this f right here, because remember this f was the derivative. So this f, and then so capital F would be the antiderivative, plus that c, that constant of integration, because again, if you take the derivative of this, that c will be canceled off anyway, but you still have to add it. So it's really important to understand that this isn't the antiderivative of this, it's an antiderivative of it. It's not the actual antiderivative because this c could be any number. It could be 0, it could be 2, it could be 3, it could be any number, negative or positive. So this is an antiderivative of this, not necessarily the antiderivative, because there's infinitely many possibilities for that antiderivative. So that's a quick tutorial about antiderivatives. If you have any questions about this, let me know.